This is a quick look regarding UART communication. We're using a UART receiver and transmitter. We're using like Vibrato, Xilinx Vibrato for its implementation, and we use Verilog HDL, which is one of those hardware description languages. We are actually going to be programming and loading an FPGA, which is actually Nexus 4 RTX7 coming up from Xilinx, and we're going to be programming, for example. Here you could see the open elaborate design, in which is showing like this is a whole bunch of like registers and a couple of modules, or for example multiplexers and a couple of adders have been employed for a receiver module. And this one right here, you could see like particularly in this board, is a transmitter that we're going to be using, and that's how it looks like. And this has actually been did a whole lot of RTL description from the Verilog that Xilinx Vibrato actually give us, and this is an open synthesizer design that I just try to map to the FPGA. So in an open implement design, we actually have the same thing that we're going to be showing right now. So you could see like in this particular, this is a whole lot of chip that is an FPGA. This is the FPGA. So this chip is actually the whole software description of what it actually looks like in reality. So you can see like this is using these many resources in FPGA, and you can like for example how it looks like. So it's kind of a little bit more complex at how these wires are interconnected. So if you could see like, for example, if you just try to click on this way and just try to mark on anything and just go try to schematic, it might just not going to be like looking properly all the times, but if you just look carefully, it's going to be giving you all the results. So we're going to be programming, we're going to be just like generating the boot stream. Boot stream is already completed because we already done this, and we're just going to be opening up the hardware manager, which is going to be used for programming the board itself. So this is actually the bitstream file that we have to make sure that we are actually loading the top module file that has been actually the design file itself. The FPGA should be actually programmed using this. So we're going to be programming it. So the FPGA is actually programmed. So this is like a power on button. If you're not pressing on, or just like not putting it on, then it's not going to be programmed. And in this case, now we're just going to be going back to this. We're going to be going to the Teratom, which is one of those applications which is going to be used for serial communication. And you can see, probably, I hope the video is visible. So this is a serial communication. We're going to be connecting the serial port. Probably we have only once, like Colmate in this case. And let's go to the setup and the serial port. And because we are using like 115,200 bit per second rate, so this data is 8-bit, and stop is a 1, and new settings. So we could see like this is actually a whole lot of setup is completed, and if you just try to like put like a Z from here, for example the Z, I press the Z, for example A. If I just try to press an A right here, so the capital A, and if I try to show you right here what's this actually printed, is this is MSB of a data bit. For example, this one is LED, this one LED, this LED is actually the MSB. Let me try to make the posture right now. So this is an MSB bit, which is actually going to be 8 right here. So the 1, 2, 3, 4, 5, 6, 7, 8. It's like a 7 down to 0. And you can see like this is actually 2 raised to the power 6, which is 64. And 2 raised to the power 64 and 2 raised to the power 0 is actually 1. So completed task is like, so completed. In this case, we can see like it's the 64 plus 1 is actually 65 for the capital letter A that we actually doing this. And if we just try to press in the B right now, we can see like the bit has actually got changed. For example, it was A and it was B, so it's got like a 1 0 in this case, like a 64, and the 62 is got 66 in this case for the capital letters. And if we want to send the data to the to the PC itself, then we can see like we have to enable this a particular LED, not a particular push button,
And if we just try to do this, then we're going to be able to see that this LED has just got lit up. We can try to see this way. So since we can actually receive the same thing even though we are actually transmitting, because it's asynchronously. And if it's trying to show you like it's getting received again and again. But if I have to transmit the data to the PC screen itself, so I'm going to be using these bits, which I actually use in the constraint file. So